Good afternoon, everyone. For those on the phone, your lines are on listen only until questions are taken. At that time, you will be prompted to press star 1 on your touch-tone phone. Please ensure that your line is unmuted, and please record your name and affiliation so that I may introduce you for your question. As always, conference is being recorded. If you have any objections, you may disconnect. Once again, you are on listen only at this time. Conference will begin momentarily, and to ask a question, please press star 1 and unmute your phone line. Please continue to stand by, everyone. Good afternoon, everyone. Thank you all for dialing in for today's conference. Your lines are on listen only until the question and answer portion of the call. At that time, please be sure to press star 1 on your touch-tone phone. Please record your name when prompted so that I may introduce you to ask your question. As always, conference is being recorded, and if you have any objections, you may disconnect. Once again, please continue holding. We will begin momentarily. And to get into the queue to ask your question, just press star 1 and record your name at this time. So stand by, everyone. Once again, for those on the phone, we will be starting conference shortly. If you wish to ask a question, please press *1 and record your name when prompted so that I may introduce you to ask your question. And as always, conference is being recorded. You may disconnect at this time. Please continue to hold, and our conference will begin momentarily. For those on the phone, please stand by. We will begin in approximately 2 minutes. You are live.
Good afternoon. I'm NASA's Megan Cruz, and thank you for joining us for NASA's Europa Clipper pre-launch teleconference. Europa Clipper is a flagship mission for the agency. The spacecraft will travel the nearly 2 billion-mile, 5.5-year journey to Jupiter's moon, Europa, an icy water world that could have the ingredients for life. NASA just wrapped up a successful launch readiness review, so we are marching towards a launch attempt tomorrow, October 14th, for liftoff at 12:06 p.m. Eastern Time from Launch Complex 39A. And to tell you more about today's review, we have here in the room at Kennedy Space Center, NASA Associate Administrator Jim Free. Sandra Connelly, Deputy Associate Administrator, Science Mission Directorate, NASA Headquarters. Jordan Evans, Project Manager of Europa Clipper at NASA JPL. Tim Dunn, Senior Launch Director, NASA's Launch Services Program. Julianna Scheiman, Director, NASA's Science Missions at SpaceX. And Mike McAleenan, Launch Weather Officer, 45th Weather Squadron at the U.S. Space Force. Okay, so each has some opening remarks, and then we'll start taking questions from the phone. For those on the line, press star 1 to get into the question queue and star 2 to get out. All right, Jim, go ahead.
Thanks, Megan, and good afternoon. Thank you all for dialing in today. I first want to take a minute and acknowledge everyone who's been affected by both Helene and Milton. It's certainly hard to believe we were here just 2 weeks ago after Helene for the launch of Crew 9. And the safety of our workforce and their families is certainly our top priority. And the Kennedy Space Center team, led by Janet Petro, has done a tremendous job at looking out for people and getting everything back online here so we can hopefully launch Clipper tomorrow. The SpaceX and NASA teams did a great job keeping the hardware safe during the hurricane, and we're looking forward to a great launch tomorrow as we send the spacecraft on its way and hopefully bring home Crew 8 later this week, assuming we get the weather to cooperate. At NASA, we often bring everything back to our mission statement, which begins with to explore the unknown in air and space. And this mission is really the perfect example of exploring the unknown in space. Europa is a fascinating destination. At NASA, we strive every day to answer fundamental questions about our solar system and our place in it, and Europa Clipper will help us answer these questions. Clipper is the first NASA spacecraft dedicated to studying an ocean world beyond Earth. It aims to find out if this icy moon of Jupiter, called Europa, could have conditions suitable for life. The next part of the mission statement is to innovate for the benefit of humanity. Clipper has some remarkable innovations, from its massive solar arrays and radar antennas to the radiation protection that's been engineered for the spacecraft, all of which Sandra Connelly will tell you about in just a minute. And the last part of the NASA mission statement is to inspire the world through discovery. Beyond Earth, Jupiter's moon Europa is considered one of the most promising habitable environments in the solar system. While we're not going to search for other life, Europa could have all the ingredients for life as we know it: water, organics, chemical energy, and stability. What we discover at Europa will have profound implications for the study of astrobiology and how we view our place in the universe. And I want to thank all the team that has worked so hard and their families that supported them along the way. Let me turn over to Sandra Connelly, who's the Deputy Associate Administrator for the Science Mission Directorate.
Thank you, Administrator Free. As the Administrator said, I am the Deputy Associate Administrator for Science, and I cannot be more delighted to be here to speak to you about this really exciting mission. At NASA, science enables exploration, and exploration enables science. I am super excited for the launch of Europa Clipper. Europa Clipper is a very important part of our Science Mission Directorate's portfolio, as it will bring us one step closer to answering fundamental questions about our solar system and our place in it. As the Associate Administrator said, scientists believe Europa has the suitable conditions below its icy surface to support life. Those conditions are water, energy, chemistry, and stability. To do this, we will be collecting data from 9 instruments and 1 science experiment. The science includes gathering measurements of the internal ocean, mapping the surface composition and geology, and hunting for plumes of water vapor that may be venting from the icy crust. Sending a mission into space is hard, and Europa Clipper is no exception. This team has overcome many, many challenges. The spacecraft itself is about the size of a basketball court and is journeying into one of the most intense radiation environments in our solar system. One of the Europa Clipper mission's main challenges is delivering a spacecraft hardy enough to withstand the pummeling of radiation from Jupiter, but also sensitive enough to gather the measurements needed to investigate Europa's environment. Our incredible teams at NASA, JPL, and industry partners have met this very difficult challenge. We've done so head-on, ensuring Europa Clipper can survive the extreme radiation environment while still delivering incredible science to Earth. The spacecraft will be the most advanced spacecraft ever to visit Jupiter. The team has figured out a way to limit Europa Clipper's radiation exposure while still dipping in close to Europa in essentially a rinse and repeat pattern. So it's dipping through the radiation environment quickly, but gathering all the data at once, and it does this 49 times as it's orbiting around Jupiter. The team has created a vault made from titanium and aluminum that will act as a shield or armor to protect the spacecraft from the extreme radiation environment while also dramatically slowing down the degradation of its electronics. This strategy was first used with our Juno mission and was very successful. The data that Europa Clipper returns will help fill in the gaps from other NASA science missions that have studied Europa, including Juno, Galileo, and the Voyager spacecrafts. I want to thank each and every member of this incredible Europa Clipper team who made tomorrow's launch possible, as well as those who will be working with us in the coming years. I look forward to the incredible and unprecedented science that this mission is going to discover. It's, again, super, super exciting, and I want to end by saying, go Falcon Heavy, go Europa Clipper, and I'm going to turn it over to Jordan Evans, our Europa Clipper project manager from Jet Propulsion Laboratory.
Thank you very much, Sandra. I'd like to begin by saying that the Europa Clipper spacecraft is ready for its ride into space and to gather more data than ever from a potentially habitable moon of Jupiter. Working with NASA's Launch Services Program and SpaceX, we've completed and successfully passed all of our final testing and inspections. We've closed out the remaining what we call red tag and green tag items that either get removed or before flight or installed before flight. We've verified the cleanliness of the vehicle from both the contamination and a planetary protection perspective with our final assays and swabs. Following those activities, we closed out our thermal blankets. We performed a mechanical walk down of the vehicle prior to encapsulation into the fairing. After encapsulation and transport out to Launch Complex 39A, once we made it to the Falcon Heavy, we've checked out the interfaces to ensure data flows through the launch vehicle to TDRS over mission control, back to mission control at Jet Propulsion Laboratory. And at this point, we are monitoring a very well-behaved spacecraft. On launch day, our team here at Kennedy Space Center will be establishing the configuration we need to be in for launch. They'll be monitoring temperatures and verifying that all the spacecraft systems remain healthy. And meanwhile, back at JPL's mission control, the team will be ready for the transfer of responsibility. Once Europa Clipper launches, separates, gets acquisition, the solar array, that all happens with a single command that we say, do launch. But once that Falcon Heavy clears the tower, responsibility for Clipper moves to our team on the West Coast. That team on the West Coast, pre-launch, they're going to ensure that all of the required ground systems and deep space network stations are ready. They'll also be monitoring the spacecraft telemetry, and they'll have a test bed, which is a copy of the electronics that make up Europa Clipper, up and running in parallel to follow along with both countdown and count up. And then following separation, that team at JPL will be responsible for assessing the telemetry and state of Europa Clipper and then flying the spacecraft from then on. Separation is our first major milestone, and that's followed by acquisition of signal. It takes a few minutes to warm up our amplifiers, and we'll be first looking for a carrier to see that the spacecraft is transmitting, and then followed by locking on and getting telemetry to assess the state of Europa Clipper. And then about 2 to 3 hours after acquisition of signal and Europa Clipper has had a chance to roll like a rotisserie and evenly warm up our solar array mechanisms, the spacecraft will autonomously cut the solar array restraints with thermal knives. And that process takes about 30 minutes from start to the cutting of the last one. After that, our journey to Jupiter takes about 5.5 years. And during this time, we will do gravity assists at Mars. For tomorrow's launch date, that's March 1st of 2025. And then in December, gravity assist at Earth in December 2026. Then we go through a quiet cruise period where throughout cruise, we'll be doing calibrations, periodic maintenance, and practicing our Jupiter orbit insertion and our science flybys of Europa. And then Europa Clipper arrives at the Jupiter system on April 11th, 2030. Being a day from launch, I must say I'm humbled to be a part of this team that overcame the challenges that come from bringing a mission like Europa Clipper to this point. I know the spacecraft and instruments are ready. I know the team is ready, and I'm at peace and confident in that readiness. And at this point, I'll turn it over to Tim Dunn, Launch Director of NASA's Launch Services Program.
Thank you, Jordan. I'm proud to be here today representing the women and men of NASA's Launch Services Program. I'm the NASA Launch Director for the Europa Clipper mission, and I'm thrilled to be a small part of this amazing team with the privilege of launching this flagship mission. Europa Clipper is the 10th NASA LSP mission to launch on a SpaceX rocket and NASA's third mission to fly on the massive Falcon Heavy vehicle. Europa Clipper will launch from historic Launch Complex 39A here at Kennedy Space Center. Europa Clipper is LSP's fourth mission from this launch pad that has previously hosted such vehicles as Saturn V and the Space Shuttle. I'd like to recognize the Falcon Heavy Europa Clipper launch team, SpaceX, NASA, the Jet Propulsion Laboratory, and the U.S. Space Force's Space Launch Delta 45. These professionals are world-class and are executing the Europa Clipper launch campaign with precision. The entire Falcon Heavy team has been busy with final launch preparations. A week and a half ago, we performed a successful mission dress rehearsal to exercise the launch team in performing a simulated Europa Clipper countdown. Then, a day later, on October 4th, the launch team held the flight readiness review to assess readiness for continued processing. That evening, our precious spacecraft, Europa Clipper, was transported to Launch Complex 39A hangar and mated to the rocket the following day, October 5th. Then the real fun began. A week ago today, just last Sunday, we scheduled a weather call to see if we could roll the rocket out to the pad a day early for our original October 10th launch date. Little did we know the weather team, led by our LWO Mike McAleenan, would introduce us to our friend Milton, whom we would all get to know well for the next 5 days. The launch vehicle and pad hardware and spacecraft all made it through the storm. We spent a lot of time on Thursday and Friday of this past week evaluating that. And then yesterday, at the launch pad, we began the process of final launch preparations by rolling the Falcon Heavy with mated Europa Clipper spacecraft out to the pad deck, followed late last night with erecting the rocket into its vertical launch position. Today, prior to this media event, we held the Space Launch Delta 45 Launch Readiness Review, followed by the joint NASA-SpaceX Launch Readiness Review. In these reviews, we verified our range, launch vehicle, and spacecraft readiness and received approval from senior leaders from NASA, JPL, SpaceX, and the U.S. Space Force to enter into launch countdown tomorrow morning. While we successfully fought through Hurricane Milton, our LWO, Mike McAleenan, assures me we will have exceptional weather for tomorrow's launch. But I'm going to let Mike talk about more of that in a minute. But speaking of Mike, I want to thank him so much for his service to our Europa Clipper team and to the many hundreds of missions that he has worked over his long and successful career. We'll miss you, Mike. Tomorrow morning, the launch team will arrive on console to perform final pressurization, vehicle checkouts, and spacecraft transfer to internal power. Then about 11:10 a.m. Eastern Time, the launch team will be polled for loading chilled RP-1 kerosene and supercold liquid oxygen propellants into the Falcon Heavy Stage 1 and Stage 2 tanks. After completion of propellant loading, along with a series of final launch vehicle checks, we'll be ready for our targeted T0 during the 15-second window that opens at 12:05 and 45 seconds a.m. Eastern Time Monday morning. We will be targeting as late in that 15-second window as possible. To summarize, the Falcon Heavy rocket and Europa Clipper spacecraft are ready, and the launch team is prepared and excited to launch this incredible mission to the largest planet in our solar system. Back to you, Megan.
Thank you, Tim. Yes, we are excited to see launch with the weather being so perfect, right, Mike? But first, let's go to Julianna with SpaceX.
Thank you. When I think about the science, what we're going to discover, and all the people who have spent 10, 20, or more years on this mission, it is just so truly amazing. What an honor we all have for being part of the Europa Clipper mission. I'm excited to be here today. We launched Psyche on Falcon Heavy on this day exactly 1 year ago, and tomorrow we'll be launching another interplanetary mission. Europa Clipper, as you heard, Europa Clipper is traveling to the far reaches of our solar system to help us better understand the habitability of Jupiter's moon, Europa, which has one of the most promising environments in the solar system that can support the building blocks of life. You probably already know that at SpaceX, we're big fans of life beyond Earth. SpaceX was founded to make life multiplanetary, and we build rockets to make that dream a reality. Europa Clipper is the largest spacecraft NASA has ever developed for planetary exploration, and it will be traveling over 1.8 billion miles from Earth, which means it needs a powerful rocket to get there. Falcon Heavy provides over 5 million pounds of thrust and will launch Europa Clipper on an Earth escape trajectory. Falcon Heavy is giving Europa Clipper its all, sending the spacecraft to the farthest destination we've ever sent, which means the mission requires the maximum performance, so we won't be recovering the boosters tomorrow. I don't know about you guys, but I can't think of a better mission to sacrifice boosters for, where we might have an opportunity to discover life in our own solar system. How cool is that? The mission has been a long time coming for many, and now we're 1 day from launch. We are so excited to be part of such an amazing mission and are incredibly thankful to NASA for the opportunity and trust. And now over to you, Mike. You've been a little busy. Perhaps work has calmed a little bit with the winds.
Yes, we have undergone quite a transition from hurricanes, and I think the next couple of days we might see some fall-like conditions finally in Central Florida and get rid of our daily thunderstorms. Weather's looking really good for the primary day. Should be great viewing. We're at a probability of violation of only 5%. We might see a few cumulus clouds around, but really very, very low chance of any kind of a threat for a violation of our launch commit criteria. Winds will be out of the north or northwest, very light, so no issues there. And that great weather really sticks around for the next day as well. For backup day, we're maintaining a probability of violation of only 5%. So that looks great. We get a little degradation in the weather if we have to go for our next backup day, our tertiary day on the 16th. We have kind of a secondary push of cold air coming in that's going to make everything feel good. But when that comes in, it creates some extra clouds. So there's a little bit of risk for that third day. But again, I think the first couple of days we have a really good chance. And so very excited. I've been hearing about Europa Clipper since Mr. Ferentz in my middle school talking about that's a place we should go. And this is a heck of a penny flight for me. So thank you very much.
All right. Thank you so much, everyone. We will now go to the phones. We have several of you on the line. Again, reminder to press *1 to get into the question queue. First, we will take Bill Harwood from CBS News.
Thank you very much. I've got a couple of quick ones here. One for Tim. Can you clarify the launch window a little bit? Are you launching is the target to launch at 12:05:45, or is it more like 12:06? I was a little confused by that. And for Julianna, can you tell us a little bit about what the second stage issue was on the Crew 9 launch, just to help me understand why we're okay to launch Clipper? Appreciate it. Thanks.
Hey, Bill. So I will answer the window question. So, yes, as I mentioned, we have the 15-second window. It does open at Eastern Time, 12:05:45. So that is what we will be targeting. We do receive our collision avoidance report about 2 hours prior to launch. We will evaluate if we have any conjunctions or seconds in that 15-second period that we need to avoid. We'll evaluate that, at which time we want to move the targeted T0 time as late in that 15-second window as practical for the mission's trajectory. The optimal mission trajectory is actually at 12:06:00 tomorrow. So that is our plan, Bill. I know it's a little bit confusing. It's a little bit different, but think of it in terms of if you have a long window and the front half of the window is blocked by bad weather, and then you just make the decision to target the end of the window. We're doing something similar to that, but because it's easier for the launch team to prepare for the beginning of a window and then move to the right, it's very difficult to move back to the left. Julianna, I'll turn it over to you for stage 2.
Yes, thank you for the question. We often at SpaceX say we will only launch when ready, and I think what's most important is that after every experience, after every flight, we always work in partnership with NASA, make sure we're ready for the next flight. So another important note about the Crew 9 flight was that at no point were Crew 9 or the Dragon itself at risk. We had an issue on that flight during the deorbit burn, during the second burn of that second stage. During the burn, the second stage Merlin vacuum engine, or MVAC engine, continued to produce thrust for about 500 milliseconds after the shutdown was commanded on the engine. That half a second of extra thrust basically made it such that the second stage re-entered the Earth's atmosphere slightly outside of the established zone for landing of that second stage in the South Pacific Ocean. On our vehicle, everything responded as it was intended. We basically commanded a backup Merlin vacuum shutdown process that closed the open engine's liquid oxygen bleed valve that successfully shut down the MVAC engine. The stage remained intact while still in orbit and broke up as expected. Again, it's a deorbit burn during reentry, and that took place over the Pacific Ocean. We have no known reports of debris reaching the ocean surface or damage at this time. And the SpaceX and NASA teams poured over all of this data together and have cleared the specific issue for the Europa Clipper. As the Europa Clipper mission is NASA authorized, this is one that we have worked in partnership with NASA. And in addition, the FAA has cleared us from this issue, and we are cleared to fly for FAA licensed mission. So.
No, we partnered, obviously, with SpaceX because of the proximity of the Crew 9 mission to the Europa Clipper planetary window. And SpaceX brought us quickly into that anomaly resolution. We held our own independent engineering review board just the day after our flight readiness review, where we assessed and cleared Europa Clipper of this anomaly.
Great. Thank you for the question, Bill. Now we have Jeff South, Space News.
Hey, good afternoon. Question for Jordan. You mentioned that you cut the cables for the deployment of the solar arrays. How long does it take for the solar arrays to deploy and for you to know that they are all working properly? Thanks.
Yes, so it takes about 30 minutes for the spacecraft to go through all 9 per side. So it does 8 per side, and then at about 30 minutes after the initiation of solar array separation start, it cuts the 9th on either side. That occurs about 3 to 3.5 hours after launch, and it'll take a little while for us to identify the state of the vehicle following solar array separation. So launch plus roughly, you can say 3.5 hours.
Thank you. All right, Gina Sinceri, ABC News.
Yes, I'm not sure who this is for, but it's kind of a follow-up to Bill's question. Why are the launch windows so short, and do they get longer in subsequent days?
So this is Tim Dunn. I'll start with that and then hand it over to Julianna. So the length of the window remains 15 seconds for the duration of this planetary window that will extend out to November 6th. So it will not change. The reason is due to the planetary nature of getting to Europa exactly when we want to. So Julianna, I'll let you pick up there.
Yeah, they call it rocket science for a reason. It takes a very, very specific trajectory. We have to deploy the payload exactly to the time and place it needs to be to continue on its journey flying by Mars on its way to Jupiter. And so for that reason, we keep as tight of a window as possible so the spacecraft team knows exactly where their spacecraft is, when and where when we deploy them. And we do, oftentimes, a lot of our missions actually have instantaneous windows, like Dragon missions. But for this mission, we made sure to keep at least 15 seconds to support a COLA, or risk of collision, essentially, for an on-orbit asset. So we have that 15-second window to play with, and that I'm sure will be good for any COLA issues.
Right, thank you. Next, Will Robinson-Smith, Spaceflight Now.
Hi, thanks, Megan, and thanks, everyone, for taking the time. Question for Tim Dunn, and then a quick follow-up, if I could. With the launch date, can you explain why the launch pushed forward a day and it was pushed back about 24 hours? And then I suppose another one that would also go to Tim just very quickly. There appears to be a Falcon 9 Starlink launch also on the schedule for tomorrow in the early morning, overnight hours. Is NASA still requiring a 24-hour stand down from Starlink launches ahead of NASA missions, or is SpaceX able to move forward with the Starlink launch and then have Europa Clipper follow it up some number of hours later? Thanks.
Hey, Will. I'll start, and again, I'll hand over to Julianna. It's a little bit of a two-part question and answer. So on the separation that you're asking about Starlinks, due to the importance of our NASA LSP missions and the level of mission assurance that we desire into it, we have always requested and worked with SpaceX to have a setback from their prior Falcon mission prior to a NASA LSP mission. It has varied through the years. We started somewhere around 72 hours a few years ago, and we've been working to get that down as low as possible. Given the nature of Europa Clipper flying on a Falcon Heavy, obviously there's 3 times the booster data that has to be evaluated on that flight, and so it takes resources from our team that need to commit themselves to be ready for Clipper. And so we actually needed SpaceX to set a 48-hour standoff from the Clipper launch time to when they would launch their previous Starlink or other commercial or even a Space Force or NRO mission. So SpaceX has been very accommodating, working with that special request that we have to allow our teams to look at that prior launch data to give us the maximum assurance that there were no flight anomalies prior to us committing to the Europa Clipper launch in this instance. So, for instance, you may see a Starlink mission is being moved as we speak on the range schedule from early tomorrow morning to what would be early Tuesday morning after Clipper launches. And so SpaceX maintains the capability should we have run into something during our reviews today where we needed to move Clipper to the right a handful of days, they would be in a readiness posture to launch that Starlink mission later this evening, now that they've received FAA clearance coming out of the Crew 9 anomaly. So that is that explains the setback there. Julianna, I'll let you take the other question.
Sure. Thank you, Tim. So to state the obvious, when we were originally targeting October 10th for our launch, and we shifted away from that during Hurricane Milton. And during that time, when our team, for example, in Hawthorne, I think actually to step back, one of the most important rules in rocketry is to stay paranoid and stay hungry. And so while our team in Florida was battening down the hatches and making sure this vehicle was safe, the spacecraft was safe, and the people were safe, the team in Hawthorne is poring over past flight data, build data, the whole spectrum of things you can possibly imagine, doing what we sometimes called a paranoia scrub. And during that process, we identified a quality control issue related to our vehicle tubing. And there's tubing on all over in different parts of the rocket. So one of the things we have done, working really closely with our NASA Launch Services Program team, is looked at what hardware on the vehicle was suspect, needed to be evaluated as part of this issue, and make sure that it had its necessary checks and validation as needed. So if it basically making sure that every system went through an acceptance test or a validation test or an additional type of inspection to make sure that the vehicle and the hardware that's on the pad vertical right now is ready to fly. And so we, as a team between NASA and SpaceX, have poured through thousands of work orders and plenty of data to show exactly which hardware we're talking about and to show that it's ready to fly. And so on the SpaceX side, that's what we work through in partnership with NASA. And as you've always heard us say, we fly when we're ready, and we're ready and looking forward to tomorrow.
Yeah, this is Tim. I'll just add one thing. So obviously SpaceX brought this issue to us. I believe that would have been very late Thursday night, sometime during the day on Friday. And we did agree with them that this was something that obviously needed further looking at. And SpaceX was very accommodating with everything that we, NASA, asked to assure mission success for Europa Clipper. So our teams worked hand in hand for most all of Friday evening and all day yesterday to get to a very confident risk posture today as we went into our launch readiness reviews. So we're in very good shape, and we do appreciate SpaceX's paranoia.
Okay, we have Stephen Clark, Ars Technica.
Hi, thank you for taking my question. I have a couple of questions, one for Jordan. Just curious if you happen to know the final launch mass of Europa Clipper after doing the anti-gravity and mass weighing of the spacecraft after refueling. And for Julianna, I think this is the last Falcon Heavy SpaceX has for some time after a very busy couple of years with Falcon Heavy missions for NASA and the Space Force. When is the next Falcon Heavy supposed to launch after this one? And can you kind of talk about the future outlook of Falcon Heavy? Thanks.
Stephen, so sorry, we only caught a little bit of your questions. I know there were a couple there. We heard the question about the final launch mass, but can you repeat the others that you had after that?
Yeah, just one for Julianna. This is the last Falcon Heavy for some time, I believe, after a very busy couple of years for NASA and Space Force with Falcon Heavy. Just wondering, when is the next Falcon Heavy expected to launch after Clipper? And can you talk about the manifest and outlook for Falcon Heavy over the next few years? Thanks.
Jordan, on the launch mass. So we came in right about 5,700 kilograms fully fueled with our biprop system.
Okay, thank you. And for the question about Falcon Heavy, so obviously we manifest missions and we support our customers' need dates. So when we have a mission right now, these things have a tendency to shift sometimes because customers have different needs. But right now, I see 3 commercial missions on Falcon Heavy in 2025. And there's a special Falcon Heavy mission I'm looking forward to in 2026, which is the Roman Space Telescope mission for NASA. So those there are definitely missions planned for 2025. but I am especially looking forward to 2026.
There's always something exciting to look forward to. All right, next is Tariq Malik, space.com.
Hello, thank you very much. Yes, I had a question about the launch windows and the delays and what that's cost, I guess, Europa Clipper for its trip to Jupiter. Given how tight the window is, do you lose any performance on the way there, given that you've had, 4 days of delay? And I think that would be for Tim. And perhaps for Julianna, does this mission really push Falcon Heavy to its raggedy edge? Is this the max capability that Heavy will be capable of, or is there still some margin in terms of lift or performance? Thank you.
So I will take the first part of the question, which is, does it cost us anything as we go deeper into the planetary window? And performance-wise, that's no. We had the 28-day window from October 10th through the 6th of November. And our trajectory and flight performance analysts have been working years on assuring that every single one of those days, Falcon Heavy is capable of making the performance there. Certainly, we ask everything. We want to get every opportunity out of Falcon Heavy, and that's why originally that window ended on the 31st of October, and we got an additional 6 days out to the 6th of the month. So that was very good. So we haven't lost anything by delaying from October 10th now to October 14th. Jordan?
And this is Jordan, yeah. So in terms of what it means to Europa Clipper, so each of the dates in the launch period end up changing the date at which we do a gravity assist at Mars and a gravity assist at Earth. But other than that, all throughout the entire launch period, all trajectories arrive at Jupiter for Jupiter orbit insertion on April 11th of 2030. So they're all well within our design and our plan.
And then from a Falcon Heavy performance perspective, as you can imagine, for an important mission like Europa Clipper, we make sure we have done a lot of trajectory analysis, a lot of performance analysis. Both SpaceX and NASA Launch Services Program independently performing said analysis to show that we not only have enough performance to support the mission, but we have enough performance to support the mission with margin. So we are not on the raggedy edge in a risky way at all. We have plenty of margin to support the mission.
Thank you to all three of you for answering those questions. All right, Jim Siegel, Florida Media Now.
Hi, everybody. Jim Siegel from Florida Media Now and O'Connor Space Tech. I think this question might be for Sandra. Assuming that this mission is successful, have you identified what might be the next steps? What other things you might take from, or other projects or other missions as a consequence? And what kind of time frame these might be? Thank you.
Yeah, so I am so blessed to have this job because we have a number of amazing science missions, and there's ones that are operating and there's ones that are in development, and then we have the ones that we're looking forward to in the future. And there's over 140 missions that range from development through extended operations. And so some of the very exciting near-term missions that are coming up, even later this year, we have two commercial lunar payload services missions. One's with Firefly Aerospace, the other one Intuitive Machines, that are going to be delivering payloads to the moon. We also, one of the really exciting things from a heliophysics or studying the sun and its influence throughout the solar system is the Parker Solar Probe. And it is going to be on its closest approach to the sun Christmas Eve, basically December 24th. So again, really exciting science coming from them. And then in 25, we're looking forward to SphereX, which is going to do an all-sky survey. And beyond that, we're looking at the Roman Space Telescope, which Julianna mentioned. We also have Dragonfly that's going to be venturing to Titan, the moon of Saturn, icy moon as well. So, there's many, many, many missions. We're looking forward to Mars sample return, bringing back samples from Mars. So I could go on and on and on and list the very exciting missions that we're doing. But thank you for the question.
Thank you, and go Europa.
Go Europa.
All right, Leo Enright, Irish Television.
Yeah, thanks very much for doing this. I'm curious about this paranoia scrub. Was there something that happened during the Hera launch last Monday that prompted SpaceX to contact NASA on Thursday late to say, maybe we should delay a day while we look at it? Was this something to do with Hera? And I have a second question, if I may, just a basic one. What time are you expecting after separation acquisition of signal? Can you give an exact time? Thanks.
Okay, I'll answer the first part. No, this had nothing specific to do with Hera, nothing to do with the Hera mission specifically. At SpaceX, like I said, we are constantly looking at not just flight data, but we're constantly building vehicles, building rockets, building engines in our factory, and like I said, we're always looking at all that data, especially ahead of a big mission like this. So there was nothing specific that came from Hera that resulted in a phone call by me. Sure. And Tim has asked me to explain what paranoia is. So basically, at SpaceX, like I said, we always try to stay paranoid and stay hungry. And so, there are a million things have to go right for a rocket launch to go well, and only one small thing has to go wrong for a rocket launch not to go well. So at SpaceX, we take what we do very, very seriously. We look tip to tail across the rocket. Again, flight data, pedigree of the actual hardware, test data, inspections, the whole thing to make sure that we fly when we're ready. So that's what you're seeing our team doing, again, especially for a mission like Europa. And I will give this to Jordan.
Very much. So in terms of when we expect both acquisition of signal and then ultimately telemetry, so at separation from the launch vehicle, which occurs right about 1 hour after launch, we start to warm up our traveling wave tube amplifiers, our tweeters for our comm system. That takes about 5 minutes. Once they get to an appropriate state and our comm behavior finishes executing, then we'll see carrier and then ultimately get telemetry. And so shortly after the hour and 5 minutes, we will be listening for it, and then it could be sometime in the next 20 to 30 minutes. We would be continuing to expect to get first carrier and then ultimately telemetry.
Next, Ken Kramer, Space Up Close.
Hi, thank you for doing this, and good luck. I'm looking forward to seeing this tomorrow. I got a science question, please. You're hopefully going to be flying through plumes, and I'm wondering, based on the Hubble data and other data, if you have any idea where they are. And can you tell me about the mass spectrometer, its capabilities, and what's the maximum molecular weight it will be able to determine? Thank you.
This is Jordan, and I'll start by saying I'm an engineer and not a scientist. So the maximum molecular weight that mass specs, I know it's capable, and I know it is extremely, we have the ability to tune it to be able to look at higher resolution to different molecular weights. But the maximum molecular weight is not a data point that I have off the top of my head. We can get that and get that out for everyone. In terms of plumes, the Hubble observations do point to a specific spot on Europa. And so from Hubble, we know where we think we saw a plume in some of the, I think it was STIS imagery. And so that happened over 2 observations, I think over 4 years apart. So we do have a UV spectrometer that would be good at detecting plumes and seeing plumes at the limb. And so we would certainly be able to geolocate them at Europa once we arrive there and start using UVS during our inbound and outbound scans of the entire disk.
Bill Harwood, CBS News. You have a follow-up question?
Thank you very much. Excuse me. I was just swallowing when you came to me. Sorry, Jesus. Hope I survive.
Take your time. Take your time. No worries.
This is for Jordan. I want to make sure I understand the orbit insertion burn. So my understanding is you guys have, 24 engines on the spacecraft? And you can fire them at, I guess, in clusters of up to 8 at a time. I saw somewhere the max thrust is 220 newtons. Is that right? And is the burn I'm sorry, guys. Is the burn 6 hours long, and does that use 8 of those engines for the entire 6 hours, or are you kind of alternating around? I just want to make sure I read those numbers right, because they're not like a normal burn. Thanks.
Sure, yeah. Our thruster configuration is such that we don't have one giant orbit insertion engine, and we don't have a bunch of very small attitude control thrusters. We have sort of right in the middle, and so these 24 thrusters, some of them obviously aren't going in the right direction. We have for an orbit insertion. They're more for roll, for example. And so during that burn, you are correct. It ends up being 6 to 8 hours. And so as a person that worked the Curiosity rover where we had the 7 minutes of terror, I refer to this as the 7 hours of terror at Jupiter orbit insertion. We'll be watching that burn. In terms of whether we're cycling through the thrusters, I don't have a good answer for that.
Okay, thanks.
Thank you.
All right, and we have time for one final question. This is Gina Sunseri, ABC News.
Yes, you talked about the collision avoidance. What article are you trying to avoid colliding with on launch?
Hi, this is Tim. I'll take that. COLA, or collision avoidance, is a standard launch process where what we're launching into space, we want to make sure does not collide with anything existing in space. So we all know there's a lot of operational satellites in orbit around the Earth, both in LEO, low Earth orbit, medium Earth orbit, and certainly in GEO. So as we transit through space, in this case Clipper, we'll be heading on our way to Jupiter. So we're not going to loiter in low Earth orbit, but we must pass through all of the Earth orbital operational planes of satellites. So we have friends over in the Space Force that do space surveillance constantly, and they are cataloging every object, both operational and inactive satellites that remain in space. And so we know where every large object and even very small objects are in space. And we get a report based on when we want to launch as to whether our launch trajectory at that time will come near or potentially worst case impact, have a collision with one of these existing objects in space. So we get what's called a COLA report about 3 hours before launch that we'll evaluate. And then we have the option, in Europa Clipper's case, of we have 15 seconds. Generally, a COLA report will say, don't launch on this second or these 2 seconds. You're not generally blocked out for minutes at a time or large blocks of seconds for one object. But you could have multiple objects that you're having to avoid. So it's just another technique that we use to ensure mission success of the object that we are launching, in this case, our precious Europa Clipper spacecraft.
Okay, and I want to turn it back over to Sandra Connelly, actually, for some closing remarks here.
Very much. I wanted to share that we have a very exciting panel that's flying along with this message, or with this mission. It's called Message in a Bottle, and it's a campaign that invited people from around the world to sign their names to a poem written by the U.S. Poet Laureate Ada Limon. The poem is titled In Praise of Mystery, a Poem of Europa, and it's engraved in Limon's own handwriting on the inward-facing side of the vault plate, which is basically protecting the electronics in the spacecraft from that radiation environment. Above the poem is a drawing that represents the Jovian system and the orbits of its 4 largest moons, including Europa. An illustrated bottle shown at the center contains a dime-sized microchip featuring 2.6 million names submitted by the public. So I just wanted to let you know that you're flying along with this mission to Europa. So thank you all. Over to Associate Administrator Jim Free.
Thanks, Sandra. I hope you enjoyed hearing about the incredible science and the incredible engineering to get us here as well. And as I mentioned, my thanks to the team and their families for sharing with us. It's been part of many people's career. Tim highlighted Mike. I want to take a minute to highlight Sandra Connelly, who will be retiring from NASA at the end of the year, and truly been an incredible career. Thank you for your service, Sandra, to us, and thank your family for sharing you with us as well. Let me turn it back over to Megan.
Thank you so much for those closing remarks, both Sandra and Jim. Yes, also extending congratulations to both Mike and Sandra for all your contributions, so thank you so much. And that will wrap up our press briefing today. Thank you so much for your interest in NASA's Europa Clipper, and we hope you can join us for tomorrow's launch attempt. Live launch coverage will begin in both English and Spanish at 11 a.m. Eastern Time on NASA Plus and NASA's social media platforms. Enjoy the rest of your day, and go Europa Clipper.
This does conclude today's conference call. We thank you all for participating. You may now disconnect and have a great rest of your day.